Welcome everyone to our panel on motivation and autonomy. Today we have some very interesting speakers. We have Christiano Castelfranchi, Christian Volcanoes, Dietrich, Dörner, and Joscha Bach. We will be talking about the some of the very pertinent questions, such as how do we conceptualize and construct artificial agents with rich autonomy? How can we use computational models to understand agency in humans and in AI agents potentially? Our first speaker today is Christiano Castelfranchi. Cristiano is the director of the Institute for Sciences and Technologies and National Research Council and the full professor of cognitive science at the University of Siena. His research focuses on the study of autonomous goal-directed behavior as the root of all social phenomena, as well as how social life shapes individual cognition. Cristiano, the floor is now yours. You may share your slides.
Okay. My slide. Okay. It's okay.
We don't see them yet.
You can see?
Not yet.
Strange. Why? Sorry. What I have to do, share the screen, condividi the screen. It's okay. It's okay now?
Yes, now you just need to enter the presentation mode. Excellent.
Okay. Okay. The focus of my talk, or my intervention, is the necessity for a hybrid modeling of the nature of mind, or a hybrid architecture, both for modeling human mind and for building artificial effective mind. And this hybrid nature, I focus on two aspects of this hybrid architecture. One is that we need two kinds of reasons: the reason of the heart, Pascal, and the reason of the reason is the reason. And the other is that we need true goal-driven action and behavior and goal method representation versus goal-oriented device, merely reactive. So let's start saying that, for example, we should go beyond the old BDI model, belief, desire, intention model, in which there are different mistakes in my view. We need to provide a much richer model of goals, motivational device. For example, it's wrong in BDI, the use of desire as the general category for goals, for motives. No, desire are just a sub-kind of goals, and they are part of a family of goals, that the goal that we feel, like needs, emotional inputs. We cannot feel all our goals, but some goals, yes. What does it mean to feel? That we are receiving a signal from the body, a sensation. We perceive our body, and this makes it a real body, our body, not just an hardware. Artificial creatures just simulate to have emotions, to have a feeling, affect. They do not feel any at all. They do not have a real body. Sensation can either come here and now from my body, giving the information about the state of the body, or be an evocation, activation of the memory of a learned experience, like somatic marker or previous experience of felt. Desires are based on felt imaginations of sensation. Needs are based also on current bodily sensation coming now from my body. Another aspect that we should abandon a BDI model, for example, is it is wrong to consider intention as an independent basic constituent of mind. Belief, desire, intention. No, again, intention is just a sub-kind of goals, a kind of goal. More precisely, intention is what a goal becomes in its processing after we choose and we decide to do something. For guiding our goal-directed action, we become intentional action. And so it is double in intention that the original part of the original object, the original desire. and intention to do, which is the action, the plan that we were able to find in order to achieve that objective, that goal. So we have to model goals, their processing and their kinds. There is a rich ontology of goals that we need: desire, need, intention, objective, project, hope, expectation, and so on and so on and so on, including duties, a special kind of goals. Very different from desires and other form of goals, duties, are goals originated by norms and can be even disagreeable, different from desire, for example. And we need also an artificial agent, norm-sensitive agent, the ontic mindset, the ontic representation in the mind of the agent. So we need the agent able to mentally recognize a norm as a norm, which is different from a personal request, a favor, an exchange, or from a use, a habit. A norm is something special, is a goal originated by some prescription, order from an authority, the will of an authority. But a norm, a real norm, for really being represented as a norm in my mind, we can decide to violate it. Otherwise, not really a norm in our mind, it's a bind. We can decide to obey or to disobey. And this creates some problem with artificial agents able to violate the norm. So this is an open question. Other point very important is that my claim to the need to distinguish between teleology, true theory of goals, the theory of true goals, versus teleonomy, the theory of other form of finalism, or finalistic behaviors. We have not to confuse true goal as a mental anticipatory representation guiding our behavior, which become an action, with other form of finalism, goal-oriented functional behavior, but not really goal-driven in cybernetic and psychological sense. True goals are the center of mind, the central aspect and function of its anticipatory nature for guiding our behavior towards. We are not to confuse true goals, in particular with functions of behavior, which are not mental goals, the unintended outcome that feedbacks and reproduce and explain that feature of that behavior, like in biological evolutionary biology, in which the animal behavior has a lot of functions, adaptive function, but doesn't understand and it doesn't represent this in its mind. Second, to distinguish true goal from B, the expected result of instrumental behavior, instrumental learning, Skinner model, that is the reward reinforcing that reactive behavior. The model necessary for B, for modeling B, the expected result of instrumental behavior, are classified, or better anticipatory classified in our perspective. So, anticipatory classified, condition, action, stimulus, response. Matching the condition, execution of the action. In anticipatory classifier, however, not only condition action, but condition action and the expectation of the result. This rule is a rule-based behavior, is based on learning, previous experience, and it's very important that the reinforcement of learning is the basis, but this mechanism is based on anticipatory representation, is there, exp. When exp matches, when there is the expected result, there is a positive feedback, both reinforcing the rule, its accessibility activation, and reinforcing the expectation, the certainty of that prediction beliefs. However, the exp in the classifier is not a goal, and the action is not a really purposive, goal-directed, goal-driven, although be finalized, is goal-oriented behavior. In true goal, I start top-down from the motivating anticipatory anticipation desire. The desire, for example, starts from that, searching for how, in bottom, what I have to do, can I reach the goal, if I can achieve it, to formulate a plan and an action. This is the typical cybernetic top-down strategy. The expert in activated classifier is just a prediction, a belief on the future, that if you realize, feedbacks on the rule and reinforce it. But the behavior and the agent remain just conditional action, stimulus response. They remain just a respondent agent, a reactive behavior to the stimuli, to the content. It's a bottom-up process, not cybernetically top-down like in Milgram retrieval model inspired to cybernetic from the desired representation. Now, the claim of hybrid mind architecture that we need both. We need true cognitive mind and cognitive agent driven by true decision, true goal, deliberation, system two, reasoning about choice, about outcome, about goals, plan, deciding, and so on, deliberation agent. But we also need agent endowed with system one mechanism, merely reactive, reflexes, automatic response, habits. So also a respondent reactive system, not a reasoned one. We need both kind of system in the architecture. But this system one and system two, contrary to the dominating literature, are not just parallel and competing with each other. No, they interact with each other. They interfere. They are also integrated. Consider, for example, the model, our model of goal-directed behavior, governed by goal and formulated sub-goal, sub-goal, sub-goal in the plan. This is the plan, goals and plan. But the lower level, the level of the elementary action I have to perform, are not the same structure. They are more similar to behavior networks. They use anticipatory classifiers, so the real goal and plan, and they're executed, implemented in anticipatory classifier. So they build a unique compressed, many-level structure. Other feature, cognitive architecture. Cognitive mind, the cognitive mind is based on representations, explicit representation, beliefs and goals, the two basic important representations, and their processing and their interaction. In fact, these two basic representations of mind interact with each other. For example, goal processing is based, is grounded on beliefs, depends on belief. Consider, for example, our model of goal processing, in which there are different step in goal processing, from the activation of a given desire of goals, then to conflict, option, selection, chosen goals, and then formulation of a plan, and then formulation of intention, then execution of the intention. The intention are just the final format of the original goals. They become an intention, and the action become intentional. But step by step in this goal processing, the belief filter, and determine the life of the goal and support the goal processing is belief-based. Another topic important is autonomy in agent. We need autonomy, but autonomy is not just executive autonomous performance ability. It is goal autonomy, and thus is autonomous choice, true decision. And this gives room to initiative, which means doing something without a request, autonomously, as your initiative. This gives a possibility for overhelp, doing more than I required, or a critical help, doing something different from my request, but better for the solution, for the problem solving. We need the full autonomy. This is goal autonomy, in which the agent might have his own preferences and decision. If I'm really goal autonomous, I have my own autonomous goal. I'm not just an obedient performer of the task. I'm not just able to autonomously execute my task. For example, I can decide whether adopt your goal, help you or not, whether to adhere to your request or not, to reject it, to refuse it. And we need that, say, autonomous AI agent for real social interaction, for efficient cooperation. Why? For example, because we need initiative in our partner, initiative in our robot, which should be based on mind reading and reading our mind in autonomous evolution, autonomous learning, autonomous planning, autonomous knowledge acquisition and problem solving, and so on and so on. But this autonomous, really autonomous agent we have to interact with has its own goal. They have their own goals. And this creates serious problem. Are there a danger in the fact that the agent, the artificial agent, is driven by its own goals? These open ethical issues is not driven just by the goal that I put in his mind by my request. And this goal put in the mind of the agent, in favor of whom are such a goal? In favor the interest of whom? And based on which values? Shared value, cultural value, which ones? Say very serious problems. Other point is that for a human-like, really social interaction, we need agent and robot able of mind reading and mind description. For real cooperation or for real conflict with our agent, they have to ascribe to us to recognize the goal in our mind and the underlying supporting belief on the basis of which we have that goal. In order to adopt such a goal, you have to understand, to represent, to have theory of mind in that goal, to help us better, also to frustrate our goal, or to change our goal by persuasion, by threat, by influencing mechanism. But in order to do that, the real social interaction should read our mind in terms of goals and beliefs, and vice versa. So we need to build an intentional stance, a mind reading description-based interaction, communication and cooperation. We need this cognitive mind architecture based on representation explicit of belief and goal and their reading. This also is very important, fundamental, for the famous explainability and transparency, now very trendy. But also for true explainability and transparency, we need a mind-reading description-based communication and interaction. Making our behavior understandable or explainable is in terms of cognitive motivational reason. Why you are doing what you are doing, for which reason, for which belief. The system S is not transparent, explainable, if it provides me its user, not its engineer, its algorithm, completely obscure, or its statistical and probabilistic data, the basis of its learning. No, it has to provide me its reasons, the reason why you're doing. That is, its motives, the goals, and its assumption, the belief. The motive, why it did so, pursuing which goal, for which intention, for which decision and preference, and which is the plan underlying its behavior. And there is some norm impinging on that, all this violation of norm, and why the reason of its action. And the same for assumption. On which basis, on basis of which belief, which data that I not have, or which knowledge, expectation is decide to do what is doing what is doing. Otherwise, we cannot really understand what is doing. You have to explain in that way. Not only we have to understand the system behavior in mental terms, the cognitive reason. Probably for a good interaction, this should be bilateral. I have to read the mind of my robot, my agent, in mental terms, belief, desire, intention, decision, expectation, and it has to read my mind in mental terms. It's bilateral. But this requires something more. It's necessary then that the agent represent its own mind in mental terms. It should have a self-mind reading, ascribe to him itself belief, desire, and explaining itself its behavior in terms of belief and desire and decision, this mental representation. So to have a good interaction, we have to have this bilateral description of goal, desire, and need, and we have to mentally share a plan. Otherwise, we cannot really cooperate and collaborate. So in my mind and in his mind, there is a plan, goals, belief, and I know this and he knows this. Okay, let's jump to this point, cognitive emotion, sorry, for arrive to the second aspect of the hybrid of measure, the different kind of reason. In our mind, we need two kinds of reason and two kinds of weights in our decision making. Goals have a double value, two kinds of weights. The reasoned value, the utility, based on reasoning and decision deliberation, and the felt value, attraction, repulsion. The first is based on argument, belief, can be explained, discussed, argumented, can change, persuade you, change what you believe, and then your intention, your goal, your preferences. But the second value of our decision and goals is just intuitive, felt, just due to some affective occasion, to somatic markers. I just feel something as attractive, repulsive, and so on. That not justify, explainable, reasonable, argumentable. The active perceived body, the body and this feeling enter within cognitive mind, the within cognitive process, the value of the goal is no longer just due to belief, reasoning, this is better for this consequence, is better. No, just a body sensation. And the more intense the sensation, the higher the value of the goal, the more intense the value of the goal. So the body can put a goal in our mind and even assign a value to that goal. It's not just a goal based on reasoning. Analogous, the relation between belief and emotion should be also reversed. The classical approach from cognitive point of view is cognitive appraisal. Believe in something, evaluate something, activation of affective reaction, visit an affective response. This is the classical model of cognitive appraisal. But now we have also the other way around. We feel something, and this feeling induces us to believe something. And the more intense the feeling, the more sure what we believe. So it's bilateral, classical model from belief to affective response, but also the other way around, from affective response to believing something. What in psychology we call affect as information, what I feel as the basis for believing. And in that dimension, we have to correct Damasio claim. In Damasio view, the somatic markers prune the tree of choices. In other terms, in a sense, they decide what to do on the basis of what we feel. This view is deviant, is wrong. We are able to combine, to calculate together both the felt value and the reason of the reason. Both. Very heterogeneous dimensions, not clear the mechanism, the model. We can decide, for example, to do something which is very important from the rational point of view. It's very useful, it's necessary. I have to, but disgusting. Oh my God, I don't like it at all. I have to do because it's too necessary. Or vice versa. I can decide to discard something very attractive. I would like very much to do that. Oh, how much I like that. I desire very much, but I cannot. I have to do this. It's more important. It's necessary, useful. So we can combine the two values, and one reasonable value can prevail on the felt one, or vice versa. We combine both. It's not true that the somatic marker prune the tree of the choice and eliminate the choice which are not attractive. We even, this is so true that we even have a meta-strategic layer heuristic, at the meta-cognitive level heuristic about ourselves, in order to manage these two dimensions interfering one with the other. And we have rules and strategy for stop one or stop the other one. For example, I can say to myself, stop, go always be so impulsive, stop, keep a cool head, reason about your decision, or vice versa. Don't stay, continue to reason, is good, is convenient, is not convenient, is irrational, irrational. Follow your impulse, So we have a meta-heuristic at the meta-cognitive level, even for managing these two dimensions, a stop one, inhibit one, or the other one. And as I say, we have goals that involve feeling, that I can feel like desire or need, more or less intensive, and goals that cannot feel, do not elicit any sensation and feel. Goals imply sensory pleasure, like desire or need, or goal without any pleasure, just rationally based. So that's my main claim on the hybrid nature or architecture that we need for modeling human mind and understanding human behavior, and also for building new artificial mind and artificial behavior. We need to have the reason of the earth combined with the reason of the reason, two systems interacting, competing, converging. And we also need to have a clear distinction between true goal behavior, goal planning, goal, the processing of goals, the goal value, and so on, guiding the action, intentional action, versus merely goal-oriented device, reactive device, classifier, system 1 and system 2, and the convergence and competence. Thank you for your interest. This is my research group. Sorry for being too confused.
Thank you.
No, it was wonderful. It was a little bit too long. We went a little bit over time. I think our chime was inaudible, but thank you so much.
I didn't listen to from the alert.
Yes, it's fine.
Sorry.
Thank you so much, Cristiano. So the Cristiano has also graciously provided an extended version of the slides, which I will be adding to the a link for in the video description once it's on YouTube. So next up, we have Christian Balkenius, who is a professor of cognitive science at Lund University. And he also is the director of the research school of the Wallenberg AI Autonomous Systems and Software Program for Humanities and Society, the goal of which is to study the consequences of AI for society. His research focus is on computational modeling of cognitive and emotional processes and their use in the control of robots. And his interdisciplinary research also looks at the areas of neural engineering, AI, machine learning, and robotics, psychology, and biology. Welcome, Christian. The floor is now yours.
Thank you. As you realized, my research focus is not very focused. Instead, I try to understand how many different things connect together. Today, I want to say something about how I've tried to approach motivation, emotion, and attention, and trying to build models of these phenomena. There are, of course, many ways to approach these areas, and many people look at, say, basic emotions or basic motivations, which is very often more of a linguistic analysis than an actual analysis of processes. And as an alternative, you could have the more phenomenological approach. But that's hard to do something that is useful for machine implementations or a robot. So the approach I think is perhaps most useful is to look at mechanisms and try to reproduce mechanisms in computer simulations in robots, as I will mention it briefly later on. And when you do that, it always turns out that these labels, things like motivation and emotion, they don't fit very well. That's not a one-to-one correspondence between words and processes, but I try to ignore that and use these words anyway. So very generally, I view these systems as something like this. So motivational systems, they tell us what to do. It's related to behavior selection. Of course, also to things like needs, specifically to future needs. I mean, we do sometimes have immediate needs, but most of our needs are future ones. And just as a simple example, something very simple like being hungry is not caused by starving right now. Instead, our body expects us to eat, and because of that, it lowers the blood sugar. We experience that as being hungry, and that's not at all a current need. It is a future one, but we experience it right now, and may select the behavior that would fit that. So the anticipatory nature of motivation is very important. Then we have emotion or emotional processing, and that's perhaps the area where there are most different views about what it would be. The way I see it is that the system that tells us what we should have done. It has to do with evaluating behaviors, evaluating outcomes, situations, and so on. So it relates to learning in various forms and things like reinforcement learning in the simplest cases. Obviously, emotion also have, I mean, that's an experiential aspect of it that I don't really study. And of course, the social aspect, we communicate emotional reactions to others and so on. But we'll ignore that for now. So one way of defining emotions that I like very much is one that perhaps most put forward by Edmund Rolls, but before him by Jeffrey Grace and others. And that's the idea that emotions are states elicited by reinforcing stimuli, which seems a bit simplistic, but it connects emotion to reinforcement learning and to evaluation of situations. So here to the right, you can see one simple, it's actually 4-dimensional space. It looks like 2 dimensions, but it's actually 4 dimensions, sort of basic emotional signals. It's not emotions in itself, it's emotional value. So one pair of dimensions goes from positive to negative, from say pleasure to pain, say hope to fear, if we're looking at more anticipatory emotions. So that's one or 2 basic dimensions. So they can actually exist at the same time. So something can be very pleasurable and painful at the same time. Actually, most interesting things in life are not unidimensional. They have both aspects. And then there are 2 dimensions that have to do with expectations. So if we expect to be rewarded, but we're not, then we might be frustrated. And of course, being frustrated could mean receiving no stimulus at all. It could be a situation with absolutely nothing. So the frustrations doesn't come from the actual situation, but from our comparing our expectations to what actually happened. Similarly, for relief, we expect something unpleasant that didn't have happened. So by combining expectation with sort of primary value in this way, we'll get 4 dimensions, but we can go on forever, which Jeffrey Gray did many years ago in his theory. So we can expect to be relieved, but we will not, and that will be a more complex combination of these dimensions. But basically, emotions here, as I see it, is used for learning and for changing the evaluation of situations and behaviors and so on. But emotions can also be motivating, which complicates things. And motivational states influence emotions. So what's good or bad, to take something simple, depends on my motivational state. Again, a simple example, if I'm hungry, then maybe food will be a positive thing, give rise to positive emotions, but I've already eaten it, will completely change. And of course, that goes for more complex things as well. And I think that binds everything together then is attentional processing. So that's the attention is the interface between both the environment and the motivation and emotional processes, and between those processes and the memory. So the way I view my memory is like a backup for the environment. If we can do something in the environment, we'll do that. If not, we'll do it in memory. But as I see it, it's basically the same processes going on. I'll get back to that in a minute. So what emotions do for the attentional system is to help decide what's interesting. It will evaluate possible stimuli, possible choices, possible objects, and so on. So given that we have simple situation with some objects in front of us, we could in principle attend to any one of them, but the emotional system will tell us that given this motivational state, some of them are more interesting. And we will then be more likely to do something with that object. Of course, this will also then influence emotion and motivation. So if we see something interesting, we'll be more motivated to do something that's related to that. Again, taking the food example because it's so simple. Say we're not hungry, but we see something tasty, then we'll be perhaps feel more hungry because of that. I haven't done much about action selection here because in many cases, stimulus selection through attention is sufficient. In most normal situations, once we have selected an object, there are not too many things to do with it. I mean, we can do a million things, but usually the action we perform is given by the stimulus or object itself. That doesn't mean that behavior selection is not important. It's just that it's not needed in very many simple situations, which may be surprising. Now, so trying to model this kind of processing.
Christian, I'm sorry to interrupt, but the audience is saying that the slides are looking static. I'm not sure if that's intentional.
Yeah, that's true. I was just about to switch to the next one. So
thank you.
Yeah, so some 20 years ago, we started to model this, and here's a new one. So the first picture I wanted to show is this one, which is a model of learning in the amygdala, in the brain. And as I said, it was a long time ago, before color was invented, so it's in black and white. It was a simple neural network model that described processes within the amygdala, which is supposed to be involved in emotional evaluation, among other things. And its interaction with the orbitofrontal cortex, which is a part of the brain that inhibits especially emotional signals. So one of the things that this model was used to was to describe how emotions become context dependent after a while. So initially we'll just react to something, but when our expectations are not fulfilled, they will be increasingly context dependent. That seems to happen through the orbitofrontal cortex. Now this model, we continue to work on that for quite some time. And most people have used it, actually use it as a control system. So it's used in industry now in the various processes, which is quite surprising. That is not something we expected. But if we look at the more current version, so here's one, and I don't have time to go into the detail, but my point here is more that today it's possible to go through the neuroanatomy of emotional processing and build computational models of that actually work and do the things they're supposed to do. So here's one extension of a model involving things like the hypothalamus and also parts of the sympathetic and parasympathetic nervous system. So we try to model, for instance, how emotional reactions influence pupil dilation and things like that. The nice thing about this kind of modeling is that we can reproduce very detailed experimental data. So in the case of pupil dilation, we have been able to reproduce nearly every experiment we found with this model. And even though each of the components here, each of the circle is one small part of the brain, but when we combine all of it, we get a lot of very interesting properties. And we can do learning experiments. We can scale the model, see what happens when it, for instance, we shine light in the eye afterwards, which surprisingly is influenced by that, and so on. And in this case, we looked also on the effect of touch on trust and how it motivates approach or avoidance behaviors. So this is just an example of a kind of modeling we are doing in my group, and this is not a complete model, but just as an example of what it looks like. So I would like to show some more sort of global views on the model. So here's one study we did rather recently, where we looked at how sort of emotional or value processing could influence decision making. So the important part of this model is a picture to the left here, and how everything is controlled by a loop, basically, starting with perception, going through memory, where whatever the model is looking at triggers both memory processes and associations with value. And this is basically the old amygdala model in a new version. So when we look at something or even think about something, that will be accompanied by an evaluation of each of those states. If we're looking around us, it will be a evaluation of stimuli around us. If we are imagining things, it will be an evaluation of that. And when we do that over time, looking back and forth or thinking about different things, we propose that there is an accumulator mechanisms that accumulate value for those different states or objects, which can then lead to a choice of one of them as actually an attentional choice, which will lead to spatial attention, which will influence our perception again. And this goes in both ways. So if we look at something, we will accumulate value for that. If we think about something, that could make us attend to it, and so on. So this is a very dynamic system that continuously works back and forth between sort of memory and the environment. And what you see to the right here is just a sort of a simple neural network that do the accumulation for the special case of selecting between two different objects. So when we simulated this, we look at very simple choice procedures, but it turns out that even very complicated things seem to use a similar mechanism. So this is a sketch of an experiment we did a few years ago, where we looked at much more complicated moral decisions. So people were asked things like, do you agree that murder is sometimes justifiable? And we had two choices, like yes, sometimes, or never. And we looked at their eye movements while they were deciding, and we could see that as people are thinking about the different alternatives, they look back and forth. And the hypothesis was that they would look more at the choice they would actually do, which actually happened here, as well as in simpler situations. But one very interesting thing was that we tested whether we could interrupt people while they were looking at one alternative, and ask them to make the choice immediately. And it turns out that people are very likely to choose whatever they're looking at if they're forced to choose that at that point. So that supports the idea that there's some sort of accumulative processing going on here. So we could actually force people to think that murder is justifiable just by interrupting them at the right time, which is quite interesting. And this fits very well with the model we're working on. So finally, I want to show this overview of an alternative version where we looked at how value processing could influence memory processes. So basically, there are systems for identifying and localizing objects, storing it in working memory, and so on. Also controlling attention through a mechanism similar to what I showed previously here. And in the center, there's a value system that modulates everything. So it will enhance processing of location or stimuli or things in working memory that are valuable. And to that, we add a gain processing, which basically controls randomness of associations in memory. So that accounts for focus, or even things like creativity. If we increase the randomness, we'll get new memory traces with a combination of a lot of things. And to the right, this just shows how this can be used, for instance, in a choice situation. So say we have simulated agent in a T maze, it can go left or right. So it looks left or right, sees a stimulus there, and that starts an associative process within the brain, within its memory. And that's what you see to the right. The transitions between different memory states. So essentially, it fantasizes or imagines going through the maze, and at some point it will reach a location like the goal state that has a value, and it will then fix on that and lock onto that, and that could be used to make the immediate choice. So this links sort of the immediate situation with memory, imagination, and then choice based on emotional evaluation. Since I'm now running out of time, I will just very briefly show this last picture as an example of what we're trying to do right now. And that is to take this model based on neurophysiology, gradually building it bottom up, and also putting it into some of our humanoid robots that we built in my lab. So with that, I thank you for your attention.
Thank you so much, Christian. That was an excellent presentation. So next up, we have Dietrich Dörner, who is Professor Emeritus for General and Theoretical Psychology at the Institute of Theoretical Psychology at the Otto Friedrich University in Bamberg, Germany. Professor Dörner has also received the Gottfried Wilhelm Leibniz Prize, which is the highest honor awarded in German research. Famously, he is the main author of the cognitive architecture called psi theory. And I believe today's presentation will touch on that. Dietrich, the floor is now yours. You may share your slides.
Well, I'm going to talk about motivation. Motivation in psychology is not very much estimated because it is a kind of counter program to cognition. And cognition is a modern direction of psychology. But this is completely wrong, I think, because I believe that, I believe it together with Aristotle, the soul is a controlling device for a body which by being controlled has life. It's a wonderful sentence because it brings two very enigmatic concepts together. That is life and controlling. And to identify well, you have bodies, you have stones and whatever things that exist on the world, and these are not alive. But if a stone becomes alive and has fear about a car which would crush the stone, then the stone would have life because he is controlled and he tries to evade the car. Okay, if you, for instance, steer a car, then the steering serves a certain purpose. The car and you should arrive at a certain goal. Therefore, by steering the car, you strive for a goal. And the simple system which strives for a goal is a control circuit, feedback circuit, or Regelkreis in German. This figure shows a control circuit. There's a tank, and this tank should be filled until the level of this red arrow here. And that could be done by open a tap. But that must be opened, and the tap must be connected to some source of water to be that this how it works. And so the control circuit works in the following way. There's a set point and the actual value. Set point is called nominal value 2. And there is calculated the difference between the set point and the actual value. And if this difference is greater than 0, then you have a need for something. Then you need water. Water is needed to fill up. And then an appetendum, that is an action which cares for the filling of the tank, is activated. And if everything goes well, then the water tap is opened and the tank would be filled. And this is a control circuit in the normal form. We have it a little more complicated here. We invented these appetender, and these appetender serve to hinder disturbances to empty the tank. And this with an appetendum, with an action to fight enemies of the tank, this control circuit is like a living being, the tiniest living being you can intend for. And if you look for the origin of life, you must find the point where the first natural control circuit came in life. I don't know whether there are speculations about how that happened, but this is very simple, and such control circuits, they exist in the normal environment, in the not living environment too. There are control circuits which have no life, but exist. Okay, I have here a kind of example of such a living system. This is well, I would say it's a living system, and it has about 3 control circuits. The first one is for fuel. The system must have fuel to heat this tank, and then we have water. This water is heated, and so steam begins to exist, and this steam, for instance, drive a system which drives the wheels, or the steering system here, and this system would be alive. And this system could be able to identify the environment, and therefore we have a third control circuit here. That is, you must look for places where you could fill up your tank. And this in a normal environment is a gas station. You should be able to identify the situation of a gas station. And if you are able to do that, you can drive to the gas station and you can fill up the tank again. This is the idea. And I just sketched such a environment for this steam engine car or living circuit or system consisting of 3 living control circuits. And here we have it. This is again the car here, and then we have a kind of town with some houses and so on, and some gas stations here, for instance, Shell, here Aral, maybe unknown in the States, but it's in Germany. And this system would be able to explore this town and find the gas stations, and then when it gets 30 and the water is not enough water, the system could find a place for water and would fill up the water tank again. And therefore, this, I would say, it's not at all, it's not a non-complicated system which just is controlled by 3 control circuits: water, fuel, and information about the environment. Okay, that's it. Very simple system, but it works, and you could have such system be similar to such systems, and they work. Okay, but it is too complicated, not enough complicated to have really a plant or an animal or even man. And we will now go on with how such more complicated systems could be realized on the basis on a system of control circuits. You must now have first an idea what kind of control circuits you need. And first you need some control circuits for basic needs, food and water, for instance. That is energy and some stuff which is needed to change food really to energy, to sugar in our system. And then you have a system which is able to regulate itself. Well, another control circuit should control the absence of pain. That is, the absence of damages to the body, and they should be minimized or they should be repaired. Then next one is sexuality. For a living system, it is not necessary. You could have a living system without sexuality, but to have a development, you need sexuality, because you need that the systems can die, and new systems could be which have another genome and are better with the environment. Sexuality, then comradeship, friendship, love, and power. Relations between the different animals could be there. And this is even very early in the development, are comradeships, friendships, and so on visible. For instance, my koi fishes in my garden pond have a very complicated system of comradeships and friendships. I would call them friendships, because I have them. Although normally this is not well, one of the attributes one would find in fishes, but they are there, and rather in a rather complicated form. Then, very important too, knowledge about the reality. The very simple living systems could just look at random in the environment to find some sugar and to eat it up, and then they would live. But much better is to have systems which are able to acquire knowledge about their reality and to orient themselves in their reality. And therefore, learning is even very simple organisms reality, and the system builds up a kind of memory, a kind of model of the environment, and then is able to act much more fuller than without that knowledge of the reality. These, in my eyes, are the most important systems, and I think this system is rather complete. But you can speak much more about what in what kind the knowledge of reality is created, and how, for instance, religions or ideologies come into the game and form and give you the form the knowledge about the reality should take. But this is another question. Or it is not another question. It's a very important question, but we could not speak about it here. Okay, these are the systems, and now we have here the image of the organization of the whole system. This is a complete soul, which you have here, and it is not uncomplicated. First, you have here the basic control circuits. I've left out most of them, but hunger, pain, affiliation, that is the relations to the other members of the group is essential. The knowledge about reality, and then competence, an estimation of the ability to cope with the environment, to cope with the reality. This is competence. Very important. Okay, how does the system work? Well, quite simple. You have a number of these basic control circles, and they all have a set point deviation, that is a deviation between the nominal value and the actual value, and this depends the strength of the motive. Well, there might be for the different systems, there might be weights for these strengths of motives. That is, for instance, pain has a higher weight than hunger. These strengths of the motives then are activate a system or a neuron, MS. Okay, MS is the strength of the motivation, but to the strength belongs the competence. That is, not only the set point deviation is essential, but the competence to gain something which fills the tank, the hunger tank or the pain tank, again, must be there. And this competence is connected with this competence tank, and therefore, when the competence is low, then the motivational strength is low. And therefore, you must define the motive strength as a multiplication of competence times set point deviation. This one. Okay. What then happens is a selection process. This is done by a suppressing mechanism, which is more and more activated, and therefore exerts a suppression to the MS neurons here, which has the same value, until only one MS survives. And this one is then transferred to the next layer, to this layer here. And this then fires cognitive processes. Okay, appetender, goal. Here we have a direct connection between appetendum and the goal. Here you have, for instance, cranberry bushes, and this could be used to diminish your hunger. Well, this is the simplest form of a cognitive activity, just remembering something, but I will not now go into details about the differentiated forms of cognitive processes. This is just this cognitive system, and the cognitive system is under control of the motivational system. This is the system on motivation. Very easily to understand it, and it is very well. It's not very complicated. And it is the same in all animals or plants, and but the control circuits are differently, and the kind of learning is different, and so on. Okay, that's the core of psychology, and within 10 minutes you can explain it. But you can explain it only in that way because you must have the concept of motivation. Otherwise, without motivation, there is no life, and now a living system, because the psyche, the soul, is nothing else but a controlling system. And we have seen such a controlling system does, and it is not at all complicated.
Okay, so let me introduce Joscha Bach in this case. Joscha Bach is a cognitive scientist and AI researcher who focuses on computational models of cognition and neurosymbolic AI. He has, oops, I have full screen all of a sudden. He's currently a principal AI researcher with us at Intel Labs in California. Previously, Joscha has taught and worked in AI research at Humboldt University of Berlin, the Institute for Cognitive Science in Osnabrück, at the MIT Media Lab, and the Harvard Program for Evolutionary Dynamics. Joscha, the floor is now yours.
Thank you, Tanya. When we are looking at motivation here, it's in the context of a larger perspective on what we call the vectors of intelligence. The idea is that the systems of the future will be not evaluated in a single dimension of performance, but rather they will have many capabilities across fields. We will no longer build systems that are task specific. We're currently building systems that are more broad and flexible. And this is in this area of deep learning, we increasingly have models that are able to perform many, many tasks, some of them which they were not even built for. But the question is, how can we get to systems that go beyond this flexibility towards generality? And this means that we are optimizing many dimensions. For instance, we need to get our representations away from operator-specific representations towards universal representations, so we can represent everything that happens in the world in suitable structures for it. Or we want to go from offline learning, as we currently have in neural networks, towards online learning, and eventually to self-improving systems that have an idea of what they learn and why. We want to have systems that go from the open loop control that you currently have mostly when you act on the world, to closed loop systems that have feedback to the environment, and eventually construct new feedback loops towards self-extending. And with respect to autonomous systems, we want to go from task-directed systems towards goal-directedness, and then eventually self-directedness. So basically systems figure out what they want to achieve and why, and what the context is. And when you have collaborative systems, you need to go from systems that show what their inner state is to the user towards explainability, so they can tell the user what their state is, or explain it in terms that the user can understand. And that also means that they have to increasingly track the state that the user is in. So they have to understand what the user can understand in a given context. And eventually, these systems have to be able to understand what the intentions are, so they can truly collaborate and adopt the goals of the ones that they're interacting with. So when we are talking about autonomous systems, we go from task-directed to goal-directed and then to self-directed systems. For collaborative systems, you go from transparency to explainability and then goal adoption. And it's of course the question, does an AI system need motivation at all? It's conceivable that you are only dealing with oracles, right? An oracle is a system that is responding in a similar way as Google search to a question that you pose to it. And after that particular task is over, the system is done with its task and goes back into quiescence. And it's different from a system that is continuously interacting with the environment and serves its own goals in this purpose. But there is not necessarily a very strict gap between such systems, because, for instance, when you look at GPT-3, that is a system that is not goal interested by itself. It has no motivation. It's just a system that is basically doing autocomplete and is creating some story or response based on the auto-completion. But GPT-3 is very well capable of creating a story about a motivated agent. And so if you put an underlying motivation or combine it with a motivational system, then even such a system is able to switch from the oracle state to something that is more agentic. What is an agent? I think that the notion of agent can be best understood when you come from cybernetics. So when you take the concept of a feedback loop, where you have a controller and a regulated system, the controller is affecting the regulated system with actuators or effectors, and it gets information about the regulated system via sensors, and the sensors tell the controller in which way the regulated system deviates from the ideal state, from the set point of that system. And there's an environment which disturbs the regulated system. And the easiest example of such a control system is the thermostat. But the thermostat is not an agent, because the thermostat is only modeling the deviation of the next frame. So it actually doesn't have a model of reality. It's just reacting. And you want to have a system that is able to integrate the expected deviation over a longer time frame and optimize over a longer time frame. And as soon as you have a controller that is able to model the future, then you will have a branching expectation horizon, and the control becomes decision making. And this is when you have an agent. So an agent basically is a controller that is able to model the future and is combined with a set point generator. So we basically have stages in which we can understand intelligent agency. The simplest system that is acting on the environment is the regulator with a feedback loop. And when you are at a modeling system, you have a predictive controller. And when you combine this with a set point generator, you have an agent. And a sentient system is one that is so general in its modeling capabilities that it can discover itself and to discover and model the relationship that it has to its environment, so it understands what it is doing and why it's doing that. And you can also go a step further and think about agents that are capable of transcending themselves, which means they link up with other agents in combined collaborative agency that is coherent and is basically instantiating agents on the next level. And humans are of that type. For instance, when we have close relationships with others, we are going to link up into a shared agent. And we also state building, that is our civilization itself, can become a coherent agent that is able to act on its environment due to the way in which people are collaborating. And in our own mind, we have a variety of agents that interact. And I think we can see the way in which we deal with reality as a perception agent, that is a system that is trying to track reality as it progresses and generates functions that predict the sensory patterns. And we have an attention system that is interacting with this perception system and is creating actively a coherent model of the world. And you have a motivation agent that is giving a motive force to the perception agent and the attention agent. And what we are looking today is mostly the actions on the structure of this motivation agent. The core of the motivation is valence. Valence is what determines the value of the operations that we can perform on the environment. It's grounded in a multi-dimensional motivation system. And at the root of valence are needs that we have. And there's a big question, what is the minimal set of needs that you would need to become an interesting agent that acts on its environment? And the most radical proposal comes from Carl Friston with the free energy principle. And what he says is basically you only need to minimize the prediction error. And this will lead you to structure discovery. And if you are trying to minimize the prediction error in a system that has set point deviations, you get all the other behaviors. And I would say that this prediction error is equivalent to an aesthetic need. It's a need to discover structure in the world at large, but I don't think that it's sufficient to understand human behavior. GPT-3 is an example of a system that is minimizing prediction error, nothing else. And it seems that the order in which GPT-3 learns things is very different from the order in people learn things. Basically, meaning is if GPT-3 is able to capture at all the long tail of style. And so GPT-3 is only looking for an aesthetic structure in a way, and not even for symmetries in it. It's also in this regard incomplete because it's not necessarily coherent. It's not directly optimizing for coherence. So I suspect that while if you zoom out long enough, there might be a convergence between systems that only minimize prediction error and properly motivated systems in order to get a system that within its lifetime, in a finite lifetime, is going to get to an interesting behavior on the world. You need to put in additional needs. And also for the purpose of learnability, you might even have to have something like transitional needs, motivational reflexes. For instance, when a baby is born, the baby does not have an understanding of hunger and thirst. These are too complicated desires, and they cannot yet be matched on actions that are available to affordances that are available to the infant. So instead, the infant has hardwired reflexes. When the baby is born, it gets hungry, it has a seeking reflex. So it will turn its head around and open and close its mouth. And it has a sucking reflex. If you put something into its mouth, it will reflexively suck. And it has a swallowing reflex. If you put liquid into its mouth, it will swallow that liquid. So if you have a newborn infant, you want to give it medicine, you just squirt it into its mouth and it swallow it regardless of whether it's tasty or not. But as a result of these three reflexes, the baby gets into a situation where it learns to connect hunger with swallowing and the satisfaction that comes afterwards. And once that learning is online, the reflexes are turned off because they would interfere with the properly learned behavior. And at this point, you can no longer give them medicine in this convenient way. And it's interesting to think about how many of these transitional reflexes we have. I suspect that many of our moral emotions are actually reflexes that are built into us before we understand the true symmetries, the economy and the game theory of the social reality. And the older we get, the more these moral reflexes are replaced by true understanding, and the moral reflexes are just no longer active because they're replaced by an understanding of what are the status of the world that we want to achieve, what are the behaviors that get us there. The individual needs can be understood as physiological needs, social needs, and cognitive needs. And physiological needs, you have hundreds of them, but there are sustenance, pain avoidance, rest, libido, and so on. Then we have a bunch of social needs, for instance, a need to affiliate with others, a need to care, the need for affection, and a need for legitimacy, which means that we try to serve internalized normative goals, a need for dominance to rise up in hierarchies and so on. And obviously not everybody has the same needs and the same strengths. There are individual differences between those needs. And we have cognitive needs, a need for competence of being basically more skillful, a need for reducing uncertainty environment, which lets us explore, and our need for aesthetics, which lets us discover structure. And each need can be understood as a target value and a current value, and the deviation
Joscha, your video froze.
the time that we have left until our need tank runs dry is basically defines the urgency. Tanya?
You froze for a second.
Okay, thanks for letting me know. So we can, the urge indicator changes over time, and the stronger it changes over a unit of time, the stronger of a pleasure signal you get. If it goes in the wrong direction, you get a displeasure signal, and both pleasure
I think you're having connection issues again, Joscha.
signals of behaviors. And in this way, structure the world based on, oh, yes, I am. So as far as I can see, everything is good here. Can you see, understand me still?
Yes, but you broke off for about 5 seconds.
Oh, okay. So both pleasure signals and displeasure signals are reinforcement signals. And when we act, we do not act directly on these reinforcements. When pleasure and displeasure happen, it's too late. We need to act on models of them. So basically on future pleasure and displeasure, on anticipated pleasure and displeasure. And the urge signals are part of a larger architecture. They give rise to priming and modulation, and to learning and decision-making in our cognitive systems. And the modulation gives rise to emotional states. So we get modulated based on our changes in our urges and the expected changes into different configurations that adapt us to the environment, and that when we perceive them ourselves, we perceive them as emotional states that we are in. And the same is true when we perceive them in others. And this gives rise to what I call the engine of motivation. So here you see a bunch of tanks. To the upper left, you see the physiological needs. At the bottom, you see the social needs, and to the top right, you see the cognitive needs. Each of these tanks can run dry, and when they do this, they create pain signals. And when the level increases, they create pleasure signals, and they interact to produce an integrated sense of valence and urgency and urge strength. And they affect a number of modulators that configure the cognitive system at any given moment. And we can use our models of needs to map them on the big five, and in this way explain personality. Basically, the hypothesis here is that personality can be understood as parameterization of the motivational system. But are needs not a hierarchy? Don't we all know Maslow's hierarchy of needs? I am not a big believer in this hierarchy of needs, because first of all, I don't think that these are needs, these are purposes, right? The needs are more basic things than self-actualization and self-esteem, which are conceptually quite difficult to understand. Or safety, this is something that you cannot measure directly. You have to construct these structures that you see here. So this is actually a hierarchy of not of needs, but of purposes, of models of needs. And what we see is that basically on the lower level, you have organismic purposes, and the next level, you have relationship purposes. And at the top in Maslow's hierarchy, you have purposes that can be integrated with the lifespan of the organism, which is basically the ego. And in our own organism or our own mind, they are not organized into a strict hierarchy. Our needs are in direct competition. They're next to each other. They might have different strengths and might be replenished in different frequency, but they are directly competing. You're not just waiting when you want to stage a revolution until you have eaten. Sometimes you will not eat for a couple of days because you have more important social or high-level goals. And of course, we have goals that are above the ego, basically what we could call sacredness, purposes that are so important that we are willing to sacrifice the goals of the organism or of the ego for it. And once we have sacredness, all our other purposes become instrumental to satisfying our sacredness, our higher meaning. There's nothing esoteric about this. It's just the way in which most human beings are implemented. And this sense of having purposes above the level of the organism is what allows us to link up into higher level agents. And I think that our ethics depends on having this notion of sacredness. It depends on having shared purposes above the ego. Basically, ethics is best understood, I think, as the negotiation of conflicts of interest under conditions of shared purpose. If you do not share purposes with anybody else, there's no reason why you should have ethics, right? You are a singleton that is interacting with other singletons. You're maximizing your own goals, and there's only game theory that you have to obey. All your interactions are going to be transactional. And if you want to have non-transactional interaction, it means that you have to act on a shared purpose. It means that you are giving something to somebody else, not because you expect to get something in return from this particular agent, but because you and this other agent are part of something larger. And you want that other agent to achieve their goals because they're ultimately also your goals as part of that something larger. So you don't need this direct return from this other agent in this context. And these shared purposes need to be given by innate needs. You cannot infer them something. There are sociopaths which are completely functional as cognitive agents. They don't have any cognitive deficit, but all their interactions are going to be transactional. And the interesting thing about our own species is that we can link up in this shared purpose, that we are able to build societies at scale, that we can build coherent agents at scale. And when we think about AGI or artificial intelligence systems that are ethically interacting with people, it means that we have to build them in such a way that they are going to share purposes with us. And these shared purposes need to play out in a coherent world, which means before we can have ethics, we need to develop a shared aesthetics of what the world should be
Joscha, you're frozen again.
Do not converge to a coherent reality that is sustainable. Okay, so it makes no sense if we have shared impulses that do not converge to a coherent reality that is workable and sustainable. This is it for me.
Thank you, Joscha. Dietrich, are you able to hear us? Oh, Dietrich is a guest again. Let me make him a co-host. Dietrich, can you hear us? You should be the co-host now, again now. Hello?
I cannot see him. Can you see him?
Yes, I can see him. He's unmuted. Dietrich, can you hear us? I think we have a connection issue.
Yes, that's very unfortunate. Okay, let's hope that he is going to be able to join us in a moment. It did work in the preparation.
Yes.
And maybe what we should be doing is for now to jump into the discussion.
Mm-hmm.
And hope that we can draw him into the discussion later.
Okay. So at this point, in this case, I would like to invite questions from the audience. You can post them in the chat. To begin with, we have several questions to the speaker to jumpstart the discussion. So what kind of algorithms do we need to compute and distribute rewards in artificial AI systems, so that they're goal aligned with the humans?
Yes, I think you need to directly give this question to a speaker. And
Joscha, would you like to go first?
I think that there can be various algorithms that do it, and eventually what is important is the functional result of the application of these algorithms. And the easiest perspective that we can have on that is probably a cybernetic one, where you have a regulation system with feedback loops. But it doesn't matter how you actually implement it. What matters is that the system is acting on something that amounts to a shared purpose. And I'm not aware of a very good model for this in the context of AI that does this in a general form. But I think that Christian and Cristiano might have thought about this as well.
Christian, do you have any thoughts?
Oh, yeah, to some extent, I mean, some form of reinforcement learning system, but not like the ones we're using today, because they usually only have one general value function for the whole system. There should be something more complex with multi-dimensional value to start with, but also not necessarily reinforcing very simple associations or something like that, but rather influencing a lot of different processes. So, I mean, Perhaps if we develop something like that, it will be more like a control system, like Joscha is suggesting.
Algorithms are not at all my domain, but let's say this point, which we need to model at different layers, emerging one on the other by self-organization. So we need the model and theory, many layers. And then we need algorithms for each layer. One is the algorithm of our brain, implementing neural activity, inhibition, activation, association. But on this basis, low level, then we have the algorithm of mind, the program of mind, the cognitive programming, which is implemented at the neural layer, but it's not reducible. We cannot really understand the behavior just with the basic description of neural activation. No, we need a functional explanation or low level, and then higher level of functional explanation at the cognitive level, and so on. So, in a sense, we have to model a different layer of algorithmic machines. Sorry for this intervention.
Cristiano, actually a question for you. In your presentation, you spoke about intention as consisting of what to do and choosing of these two aspects of the goal and the actual choice of executing. How does this architecture lie within the system 1, system 2 distinction?
Okay, thank you. For me, it's basically it's part of system 2 because it's based on believing, deciding, arguing, reasoning, and then doing. But as also Bach, Joscha say, and also Cristiano, we have to integrate the system 1 mechanism and devices as the basic structure implementing even intentional action. So at the end, it is performed by automatic mechanism. And vice versa, it's possible to transform an intentional device and read a decision in an automatic habit by use. For example, when I start to drive to learn the driving car, I reason about, oh, I have to stop, oh, I have to, then become an automatism. And vice versa, it's possible that automatism is make explicit and become a decision-making process. So I start to be automatic and decide to control and decide. So it's possible the implementation of the two systems and the conversion to system, the competition and collaboration, interference, but it's also possible that one is translating the other. Currently, people with the theory of system 1 and system 2 are not so clear on that. They usually present them as two parallel and competing mechanisms stopping one and the other. This is too simplistic. They interact, interfere, and they are translated one in the other. So it's a bit more complex than maybe. Thank you for your question.
We have a question for Joscha and perhaps also for the others. Do we have a theory for high-level agency? It seems from what you said, Joscha, that game theory isn't enough, at least naively. This is from Mohammed Barakat.
Yeah. So first of all, to the system 1, system 2 distinction, I think that Cristiano is exactly right, that they're not separate, but they have to be understood as something that is working together. But there are different operations taking place in system 1 and system 2. It seems to me that system 1 is primarily perceptual, and it's getting to its understanding of reality with some gradient descent, which means it is following a deviation to a local optimum in perception. And if you are following a gradient, you don't need to have a memory of where you came from. You just need to follow that gradient until you end in the local optimum. But if the search space is very large, for instance, the space of things that we could be looking at any given moment based on the models of reality that we know, we often don't converge. And so we need to construct a solution. And this construction of a solution, when you cannot follow a gradient, does require memory, because you need to remember what you tried and why, and which things you tried worked and which one didn't. And this it will discover its own index memory, its own stream of operations that it did. And so we have a reflective system that has memory and is able to perform analytic operations, grammatical operations, and get to a low-dimensional representation of reality that is very stable. And you have the perceptual system that is much more dynamic and more continuous, and that interacts with this reflective system. And I suspect that the reflective system is primarily a top-down process, whereas the perceptual system is primarily working bottom-up, but they have to work together to work at all. Right? I don't think that one can work without the other. Now, to the question, if we have models for emergent higher-level agency, I think that it's interesting to look at the work of Thomas Aquinas in this regard. Thomas Aquinas has discovered concepts or policies for rational agents. And he says that basically every rational agent can infer that when it's in some kind of social context, that it needs to optimize for 4 different things. One is, the first principle of rational agency is goal rationality. You need to pick the right goals and the actions that you can hope to achieve these goals. In his old language, he calls this prudence, right? Wisdom. And then you have to have optimization of your internal regulation. You need to regulate your own needs in such a way that you don't fall apart, that you don't overeat, that you don't eat, that you maintain your homeostasis of your organism. And this is what he calls temperance. You also need to optimize the interaction between agents and keep them in balance and homeostasis. And this is what he calls justice. And then you need to maintain the correct balance between exploration and exploitation, which means you need to both learn, and then you need to be able to act on your models, and you need to understand when you need to act on your models. And this is what he calls courage. And these are the principles of rational agency. They are not giving rise to higher level agency. If you want to build a higher level agent, then you first of all need to submit and serve a higher level agent, right? You need to recognize that there is a higher level agent that you want to be part of, and you need to be willing to serve it. And this is what he calls faith. And you need to be willing to link up with the agents around you to do this, right? Not just in an abstract sense that you abstractly serve some higher level agent, but you need to do it with the people around you that also share this need to serve the higher level agent. And this discovery of shared purpose above the individual, this is what he calls love. And then you need to be willing to do this in the absence of expected reward, because before you act on this higher level agent doesn't exist. Right, before the higher level agent exists, it cannot give you the better environment that the higher level agent can construct for you. So you need to be willing to invest into this thing before it exists. And this is what he calls hope. Right, and in the language of Thomas Aquinas, these rational policies are called the practical virtues, and the next level agent forming policies are what he calls divine virtues. And we are used to take these things as superstitious or religious, but and the concepts that are connected to them as such, but they're not. I think that they're entirely rational in the way they were conceived. And it's just that there are, our world is so steeped in them because we used to be a religious world until 150 years ago, that they seem to be ubiquitous and part of the previous civilization. But I think that he made a genuine effort to discover principles for emergent next level.
There was an interesting remark in the chat during Dietrich's presentation. Dream is no longer a component. So it inspires me to a question of, well, what role does dreaming and imagination play in autonomy and goal formation? And I would like to ask Christian Volcanoes for his thoughts.
Okay, so the way I view it, the sort of basic mode of the brain is just imagining things, more or less a complete mess, but tries to follow what's happening outside the head when possible. So it's like we have a world outside, including the body, continuously evolving over time, and what the brain is trying to do is to follow that with sort of an internal process that follows along as well as it can. But that's during learning, but it can also be decoupled from the environment, and that means that those state transitions that it has learned just goes on its own inside the head, more or less. And when they're not controlled, it will be daydreaming or imagination. And depending on this factor I talked about, gain control, it can be completely random, or it can be focused on a particular problem or aimed at solving a problem, for instance. So in my view, the system used for daydreaming and for imagination and for planning and problem solving is the same. The difference is to what extent it's controlled or limited to just states that are relevant for whatever we're trying to think about. But that's the short version. The long version is very long, so I think I'll stop there.
Thank you, Christian.
I
Joscha.
had a remark to this, and the audience is dreaming the default state for which you can create the awake. And I think that's basically correct in the sense that everything that we perceive is by its nature a dream. Right? It's if we can perceive it, we must dream it. A physical system doesn't have any awareness. You can only be conscious in a simulation. And what we perceive is a game engine that is generated in our brain that is tracking sensory data. And at night, this game engine is not tracking sensory data because it doesn't receive any and is dissociated from the sensory processing. And instead, it augments data by varying the states of the low-level systems, so you can experience things that are not grounded in direct sensory experience. But the system is initially trained by having access to this outside world and by tracking these patterns. So our dreams tend to be heavily inspired by the patterns that we perceived in the real world interaction. But I think it would be very helpful if more people in general, for epistemological reasons, were aware of the fact that everything that they can possibly experience, think, every revelation that they have, and so on, ultimately is a brain state. Everything that we perceive is a configuration of our own brain, some kind of dynamic pattern that unfolds, and that is attended to by a reflective system that has memories of what it attended to. So we only have access to the things that we have that we remember having attended to, and what we attend to are always states that take place in our own brain. At least that's the most sound theory that we can observe. That makes sense of what you can observe. And because this system is during wakefulness coupled to the external world, we can make a model of what representations are the result of that coupling. And the functions that best predict the next sensory state are what we perceive as perceptual reality. I think this is how it works. But to this original question, I think that also implies that without the ability to dream, a system is not able to have the ability to make sense of the world, because it's difficult to build a cohesive function of the entire universe that you can relate things to. And when we talk about understanding something, when we understand the meaning of something, it means we establish relationships into a universal, connected, coherent model of everything. And this universal, connected, coherent model is what we individually call the universe. Right? Everybody creates a universe in their mind as a dream and relates everything to it.
Thank you, Joscha. We have another question for you, which I think would also be great if we could get Cristiano's input on that. And the question is, so I'll just read it. This is more of a non-technical question, but are there any immediate strategies you are sympathetic to of applying these notions of coordination and higher agency agencies to improve or increase the agency of the social structures we currently live within. What do you think are the factors driving the seeming lack of agency within our current civilization model? And do you see a steady state dynamic emerging from the current situation? Joscha, I'm not sure if you would like to go first or whether you would like Cristiano to go first on this question. Cristiano, would you like to go first?
I'm not sure that I fully understood the question. Sorry, because I wasn't able to read.
Yes.
But the interest was about the coordination, agent coordination, the emergence of collective result and sociality and so on, if I understood. There are two phases. One is we need grounding and founding sociality, social relationship, which are not just cooperative, but are also conflictual and competitive. Conflict is part of society, it's a fundamental part. No conflict, no democracy, to give you an example. So it's cooperation and conflict. And it's not only adjusting my behavior to the others, but also changing the behavior of the other, influencing them and changing their mind. Usually there is a misinterpretation of Tom, or theory of mind. It's for predicting, understanding, and adjusting. No, Tom is basically for changing the behavior of the other, influencing them and changing by changing their mind. So we have to, one part of the important theory is to ground the sociality in different aspects in the mind of the agent. And not only exchange, game, interaction, but also collective something. The emergence of a distributed collective will, of distributed collective knowledge, something which is very, very, and even more difficult, the institutional layer. The count as effect of certain action and objects socially established. So these different levels of sociality, how they are implemented in the mind and they work through our mind, for example, norms and so on. This is one aspect. The other aspect is we need a theory, a behavior-based theory, and also evolution-based theory of sociality, the kind of interaction in sociality. And on that point of view, let me say that I have enjoyed very much Dörner critics to the simplistic statistical use of correlation and so on. But I have another criticism, which also refer to some question about the game theory and so on. Careful, many theories are in fact ideal typical, are in fact normative theories, very strange one. In economics, that's the way. Game theories, that's the way. They are the ideal way, the rational behavior, but no, it's not a real completely scientific theory. Scientific theory should be explainable the fact, empirical, not just a normative ideal. So we need a complex also based on different kinds of sociality. I will be very short. For me, the basic of sociality, of all social phenomena, external, is dependence. The fact that the agents are not able to achieve all their needs. We have a limited ability, limited competence, limited knowledge, limited resources. So we are dependent on the other. We need the other. And this is the advantage of being different, complementary. So sociality is based on dependency networks and relationship. Who needs what? Not only exchange, very different kinds. Exchange, I need this, you need that, but in selfish interaction, like Adam Smith theory, or also for true cooperation. We share a goal, we have a common goal, we have to associate our power in order to achieve the common goal. Completely different. But even more, even altruism. I don't expect any at all. I just do that for you. And so on and so on and so on. So we need a more systematic theory of different form of social relations interaction that for me are based on different kind of dependency. And we need to ground that, to found that in the mind of the agent, because he is the mind that controls the social behavior. Sorry if I've been wrong.
Thank you so much, Cristiano. Dietrich is back. Dietrich, can you hear us?
Yes, I can hear you, but I can only see you in a very blurred image. And I'm so sorry. But please don't take any, well, don't look at my problems. This is just continue the your meeting, and I try as good as possible to follow.
Dietrich, what do you think are the minimal needs that you build into a system to give it sociality and social agency?
Please again, I got only the half of your speak.
Okay. What do you think are the minimal things that need to be built into a system to give it something like social agency? So that you have collaboration and competition and the emergence of normative structure.
Well,
do you have thoughts about this?
Our mice have social competition, and they have social, they behave socially. For instance, our mother mice, they look for their children and feed them and teach them things, how to come to a certain place or not. And this is very necessary to do that. And this partially developed by genetical, genetics are great in simulation. Because if you have a gene pool, a lot of things you have not to program, but they develop for themselves. And this is quite interesting. And I think this is a good medium to start with, to simulate just human development. And this is quite interesting. And then you get different forms of behavior. For instance, there must be a basic need for contact. This is basically, but when you have this contact, and my fishes in my pond, they have that. They look at me and they know me and they like to have contact with me. They don't ask me, but they wait, for instance, that I give them food. And they don't not await then from other people, but for me. That is, they have a connection with me, fishes. And they have contacts, even they have social structures, these fishes, koi carps, and everything in a rather primitive form. And to have a genome and sexuality helps a lot in development. And I would like to go on with our main problem at the moment, to develop language, not just artificial language, easy to make, but to develop that kind of language I told about a quarter of an hour. And
okay, we lost Dietrich again. The gods of the internet are not with us with respect to our connections to Bavaria. I'd like to briefly also emphasize this point that Cristiano just made, that collaboration and competition have a relationship between them. I suspect that our need to collaborate and our ability to collaborate is the result of an evolutionary pressure that was a competitive pressure. Basically, the agents bind together and form coherent behavior because they are forced to, because they are competing with systems that have discovered the power of cooperation. And once you have that power of cooperation, you are able to organize yourself in governed structures. And these governed structures mean that you are doing things that are not optimal for yourself, but that are optimal for the group, basically for the next level agent, for the next unit of organization. And as a result, you're able to collectively outcompete individuals that are only acting on their local own self-interest. And if you take away this pressure, if a system becomes too big to fail and the competitive pressure falls away, then the system loses the need, the evolutionary pressure towards collaboration and cooperation, which I think is what we might be observing in our own societies. And as a result, what we see are increasing failures of coordination. Right? So our inability to coordinate, for instance, in the face of a pandemic, is probably the result of a change of governance structures in the last 50 years as a result of our society becoming very safe and too big to fail in a way. Right? There was an absence of competitive pressure from the outside, the fact that we have weapon systems that protect us effectively from any outside attack and so on, and the fact that we have built an agriculture that is feeding us very well and a political system that is relatively stable have removed the need for deep cooperation. And so in some sense, that's the way in which agents organize to next level agency is the result of pressures that exist in the environments of the agents. And this is related to what Dietrich was describing in his simulation of simulated mice. He builds environments where there is a benefit from competition at first, because there are limited food resources. And the environment is also set up in such a way that there is a benefit from cooperation. So they can share information, they can define the food sources against other groups of mice. And as a result, there is an emergent social structure. I think we are on the top of the hour. And I would like to take this opportunity to thank all speakers for joining us today. And I'm very grateful for getting us together despite the connection issues. I'm very happy about the possibility of having such a conversation over the internet and via Zoom. I'm also very, very grateful of having met Christian in person and seeing Cristiano again after many years, and also Dietrich. We will cut this video into a form that we can release if everybody is okay with this. And I would also like to thank the audience for following along, asking questions, and paying attention. And we'll see you next time. Thank you very much.
Thank you for your beautiful initiative.
Yeah, thank you very much.